Hello, the topic of this video is about the imaginary number that is represented by the lowercase I. I is the square root of -1. Now, there is no real number that can have a negative result when being squared. When a number is squared, it's simply the number multiplied by itself. So that means the signs are the same, either both positive or both negative. So when signs are alike or the same and are squared, then the result is always positive. Therefore, if you find the square root of a squared number, you should have that number either as a negative or a positive. But if you have to find the square root of a negative number, then that's where the situation becomes complex. So there is no such thing as a number multiplied by itself being -1. Therefore, there is no real solution for the square root of a negative number. So usually -1 is factored out under the radical sign, giving you the square root of -1, which is represented by the lowercase letter I. Now let's look at the square root of a number x being squared, so we can later understand the concepts to follow with the square root of -1. So as you can see, the square root of x being squared is the square root of x multiplied by itself, which is also, using radical notation, is that number multiplied by itself when combined under the radical, which gives the result as that number x. So in essence, the square root is cancelled by being squared. Now recall that I is the square root of -1. So I squared is the square root of -1 squared, which is the square root of -1 multiplied by the square root of -1. And using the result that was shown in the bullet 1, you get the number that's inside the radical symbol. But if you use the rule of radical notation or operation, where you combine the radicand and perform the operation inside one radical, then the result is not the same for -1. In bullet 4, you have a result of +1. So bullet 3 is not the same as bullet 4. So the accepted solution is to have the radical symbol be cancelled when it's being squared. Therefore, the operation performed in bullet 4 is not accepted. Now let's solve some powers of I. I squared equals I multiplied by I, which is -1. I cubed is -1 multiplied by I, which gives -I. I raised to the fourth power is -1 multiplied by -1, which is +1. I raised to the fifth power is -1 multiplied by -1 multiplied by I, which gives +I. So now we can use these first four bullets to solve for any I raised to any power that is an integer. For instance, let's look at I raised to the 15th power. we can use the rule of powers and factor out 5 and 3, which when multiplied together gives 15. So let's choose I raised to the 5th power raised to the 3rd power. Now I raised to the 5th power, when we looked at number 4, we see that it's positive I. So now we have positive I raised to the 3rd power. Now I raised to the 3rd power, we look at bullet 2, which is negative I, and that's the result. Now let's choose I raised to the 3rd power raised to the 5th power. So we have I cubed raised to the 5th power. Going back to bullet 2, we see I cubed is negative I. So now we have negative I raised to the 5th power. So now we must always remember this following procedure. We need to factor out the negative 1. So now we have negative 1 multiplied by I, which are both raised to the 5th power. So now we use the distributive rule, where we distribute the 5 or 5th power to each factor. So now we have negative 1 raised to the 5th power multiplied by I raised to the 5th power. So any negative 1 number that's raised to an odd number power gives you a negative number. Any negative number raised to an even power number gives you a positive number, 1. So in this case, we have negative 1 raised to 5, which is odd, so that result will be negative. So we have negative 1. So now we have I raised to the 5th power. So we look at bullet 4, and I raised to the 5th power is positive I. So now we have negative 1 multiplied by positive I gives you negative I. So now you can see you can use the first 4 bullets to solve for any problem that has I raised to an integer power. This is a graph of the imaginary and real number lines. So you can see the relation with respect to I and the real number axis.